Here's a question on compound angle formulae, basically trigonometry. You are given that the cosine of A minus B is the same as the cosine into bracket pi over 2 minus A minus B. This information is actually given here just for us to know that the angles A and B are actually acute. So they are angles that are less than 90 degrees. Otherwise, we don't need it to show this piece of information. All we need is this second statement there. So the first statement there just shows us that these angles are less than 90 degrees, okay? And so how are we going to show this? We can see that sine A minus B over cosine A minus B must be equal to 1. In other words, if I divide both sides by cosine A minus B, then I have that sine A minus B over cosine of A minus B must be equal to 1. Okay? We can show from here that this is in fact sine of A plus B. I will see if I can show that later, but I don't really need it to show this result here. So what does this say? If I open this using the compound angle formulae, we know that sine of A minus B is the same as sine of A cosine of B. This is minus, so minus sine of B cosine of A. And in the denominator we have cosine of A minus B. Cosine of A minus B is the same thing as cosine of A times cosine of B. And if this is minus for cosine, then this must be plus. And we can say sine of A, sine of B, like that. All right, next, what we want to do is to divide top and bottom by cos A, cos B. Oh, by the way, this is equal to 1. So if I divide the top and the bottom of this expression by cos A, cos B, then I will have, I don't know if this space here is going to be enough, but let me just try. So I'm going to have divide by cos A, cos B. That will give me tan of A. Okay, so let me just write this somewhere here to show you, and then we can show it with just one, and then we don't have to do it again. We can see here that sine of A cos of B, if we divide by cos A, cos B there, cosine of A, cosine of B, this cancels, and I have sine A over sine B over cos A, which is tan of A, and that's why I have tan of A there. Okay. So I'm dividing the top and the bottom by cosine of A, cosine of B. So if we do the same here, all right, cosine of A, cosine of A, cosine of B, then this is going to become tan of B. And then I can divide that by, do the same, divide by cos A, cos B, that becomes 1. And this becomes plus tan of A, tan of B. Okay, and all this is equal to 1. If I cross multiply, so the denominator here is, so I can write this as 1 over 1 and then cross multiply, I'm going to end up with here, I'm going to end up with tan of A minus tan of B is equal to, I think there's a problem there. So I end up with tan of A minus tan of B must be equal to 1 plus tan of A, tan of B. And now what I'm going to do is I'm going to collect like terms together. I'm going to put this on the other side, and I'll write tan of A minus 1. So this 1 goes to the other side, and I bring B to this side and factorize it out, and I'll have tan of B into bracket, right, this and that, and I get tan of A, okay, plus 1. Okay, Now if I divide both sides by this bracket, tan A plus 1, I get tan of B equals tan of A minus 1 over tan of A plus 1, which is what the question is asking us to demonstrate. Okay, so we have shown that if those statements are true, then tan of B is the same as tan A minus 1 divided by tan A plus 1. And this is holding true because A and B are acute angles. All right, I hope this is clear. I hope that is clear. If you need further clarification, let me know. Of course, to be able to answer this question, you need to know your trigonometric identities. These are the compound angle formulas. You should be able to expand sine, whether it is sine A minus B or sine A plus B, cosine A minus B, cos A plus B. You should be able to expand that, and if you can expand that, then it makes life very, very easy. Okay, so this is not a difficult problem if you know where you're headed. All right, we will look at the next.